Okay. I think we're just about good to start. Oops. So, let's do it. What's up, everybody? My name is Phil Butler. I'm going to be reading, well, later I'll be reading, but first I'm just going to, oh, this is not even, okay, now let me just be playing. So, I'm going to be, this is probably going to be like a part 1 in a series where I go through the demo, the blog, the paper, the code, and the did set, and take notes on SAM, Segment Anything Model by FAIR, Facebook AI Research, aka Meta, aka Facebook, aka Drop My Apple Pencil. So, right now it's 12:45 a.m. I haven't been able to sleep recently, the last couple days, so I've been like, I want to make use of time when I can't sleep. So instead of just like laying in bed for hours, which sucks. So this will be one of those things I do. So how long will I go for? It's already 12:45. I spent like 25 minutes just setting up this stream and making a thumbnail and stuff. And I haven't looked at anything, so that's what we're going to be doing together. So I mean, I'm ready. I got some snacks. Everything's queued up. I got some software to stream. I don't know if we'll get to this tonight, but I got some software to stream. I can't focus. Yeah, stream the me annotating on the screen. So the majority of this things will probably look like this. Maybe I'll make my face smaller, etc. But yeah, I'm basically just gonna go through this out loud. I'll probably not really be live. It'll probably just be me talking to myself, but that's totally cool. Just doing it for the record, live, I suppose. But all right. So maybe we'll go for an hour, or maybe I'll just actually exhaust myself and then do sooner, but we'll see. But anyways, let's get right to it, right? Let's check out the demo. And I haven't checked out any of this, by the way. But something I wanted to comment on is that it's really cool being into ML research these days. And I think Meta and OpenAI and Google and all the the big players, they've sort of now defined how to release new things. You gotta have some sort of project page of a demo, and then everyone else, maybe you could pop your demos up onto Hugging Face Gradio demos maybe. Or spin up something using Lightning AI. It's just some different ways of getting your demo out there for people to actually use easily. If your blog, I guess it's also the same thing as the demo page. So here's the demo page. We'll try it on a sec. Here's the blog page. I'm assuming mostly summarizes the paper. Maybe another way of writing the paper. Actually, this looks like this is the paper. My voice, man. I'm gonna be drinking seltzer, which I kind of hate drinking anything carbonated in front of people because I end up burping. I just can't not. So, excuse me in advance. So, we'll then actually go into the PDF, into the paper, and I've been trying to formalize a method of reading papers. So for everyone else who wants to be reading papers and stuff, sorry, itchy ear. In the description, I have a Google Doc, which is a template for reading. I mean, it's basically tuned for modern deep learning papers. So that's a nice template. It's a nice companion. There's a link. You can just like copy it to your Google Drive and then rename it to whatever paper you're reading. And then yeah, and I think taking notes while you read something and annotating it, etc., is the best way to read it. So definitely not tonight, probably not tonight or anytime soon. We'll go into the code here. Yeah. All right, so let's do it, right? Let's do this demo. Okay. So find a photo in the gallery or upload an image. I hear something playing. I don't know what that was. But let's make this make sure this is visible. Okay, hopefully my computer can keep up with all the stuff I'm doing. Okay, so I guess we'll try a couple. Yeah, music is here. I guess I still have Photoshop open for making that thumbnail. I'll quit that. I pulled up Discord. And I'll just, take off anything I'm not using. Okay. I guess we don't need music, but do that whole sound check. Oh. Might be Spotify. Might be. I can't hear anything. And that's. Okay. My microphone's set to my MacBook, so at least. I'm assuming the stream is still working. Why would this not work? So interesting. This has never happened. I guess we should just forget it. I guess no music, because I want to actually start doing this. It's getting late. Let's try one more thing. Okay, so it must be my AirPods. Okay, well that fixed it. Okay. So maybe you guys probably heard, whoever's watching probably heard that music the whole time. Anyways, let's do this demo. Okay, let's pick some of these and then I'll pull some images up from my computer. Okay. Did I even mention like what this is? Maybe we should start with the blog. So I'll read. Introducing Segment Anything. Working towards. Oh wait, I realized I wanted to. I'm too shy. I kind of wanted to comment that I was doing this on his post, but I can't be scared about that. Let's just do it. Let's just comment it so that readers can. Oh my god. Alright. I'm gonna comment it. I'm gonna do some shameless self promo. And clearly my brain's not working, so I'm about to embarrass myself, but that's fine. Alright. Starting a series where I dive into this live. First episode. First one is right now. Come learn. YOLO. Okay. Let's go. Introducing segment anything. Working toward the first foundation model for image segmentation. So, what's a foundation model? A foundation model is a large, the largest so far machine learning model that is, in the case of GPT at least, it's trained on a lot of unsupervised data. So the data isn't labeled, and the thing is, you're training it not for a specific ML task. So I hope I can explain this clearly. So the unsupervised data is like a lot of text on the internet, and then the actual task is next token prediction, and this is all in the case of GPT. And then the unsupervised data gets converted to the supervised data because the labels just become the next token. Okay, so I should try not to go on too many spiels because people may already know this too. But so a foundation model, you train it not with a specific task in mind, and you train it on a lot of stuff, and then you can then later fine tune it for a specific task. And then so just to make the analogy, I want to be careful about making this analogy because I might be wrong, but GPT is the foundational model, and then the reinforcement learning from human feedback in a way is fine-tuning it, but I don't know, that might not be the best way of describing it. But let's actually read. Enough of my interjections. Now I'm just going to be a presenter. I'm not going to inject too much. So, yes. So, let's get this playing while we read. Segmentation, identifying which image pixels belong to an object, is a core task in computer vision and is used in a broad array of applications. From analyzing scientific imagery to editing photos. But creating an accurate segmentation model for specific tasks typically requires highly specialized work by technical experts with access to AI training infrastructure, like I said, and large volumes of carefully annotated in-domain data. Today, we aim to democratize segmentation by introducing the Segment Anything project, a new task, dataset, and model for image segmentation, as we explain in our research paper, which we will dive into later. We are releasing both our general Segmentation Anything model and our Segment Anything 1 billion mask dataset. Wow. 1 billion? as you will learn in machine learning, sometimes the data sets are harder than usually, in a way, like the data sets are harder than the models in a way. But then, now we can just use AI to help us generate those data sets. Okay, onward. Like I said, no more introductions, I'm sorry. We're making we're releasing the model and our data set, the largest ever segmentation data set, to enable a broad set of applications and foster further research into foundation models for computer vision. We are making the SA1B dataset available for research purposes, and the Segment Anything model is available under permissive open license, Apache 2.0. Check out the demo to try SAM with your own images, and we'll do that in a second, but I realize I should probably read this first. Now, reducing the need for task-specific modeling expertise. Reducing the need for task-specific modeling expertise, training compute, and custom data annotation for image segmentation is at the core of the Segment Anything project. To realize this vision, our goal was to build a foundation model for image segmentation, a promptable model that is trained on diverse data that can adapt to specific tasks, analogous to how prompting is used in NLP models. However, the segmentation data needed to train such a model is not readily available online or elsewhere. I'm just rereading. The segmentation data needed to train such a model is not readily available online or elsewhere, unlike images, video, and text, which are abundant on the internet. Thus, with the Segment Anything, we set out to simultaneously develop a general, promptable segmentation model and use it to create a segmentation dataset of unprecedented scale. SAM has learned a general notation of what objects are, and it can generate masks for any object in any image or any video, even including objects and image types that it had not encountered during training. SAM is general enough to cover a broad set of use cases and can be used out of the box on new image domains, whether underwater photos or cell microscopy, without requiring additional training. A capacity often referred to as zero-shot transfer. In the future, SAM could be used to help power applications in numerous domains that require finding and segmenting any object in any image. For the AI research community and others, SAM could become a component in larger AI systems for more general multimodal understanding of the world. For example, understanding both the visual and text content of a web page. Excuse me. In the AR/VR domain, SAM can enable selecting an object based on a user's gaze, then lifting it into 3D. For content creators, what I am now, SAM can improve creative applications such as extracting image regions for collages or video editing. Yes. SAM could also be used to aid scientific study of natural occurrences on Earth or even in space, for example, by localizing animals or objects to study and track in video. We believe the possibilities are broad, and we are excited by the many potential use cases we haven't even imagined yet. Alright, I do need to interject because this does make me very excited, because I think it's good for people to, I suppose, remain stoic about a lot of these things so that we can evaluate them objectively. And what I worry about sometimes is like whatever, like, you know, what catches headlines and stuff. People worry about the negative effects and everything of AI, but it's also like, just think about all the progress we can make on all these other scientific things. And I don't know. So, all right, let's keep going. So let's just look at this together for a sec. Gaze-based object detection. So, all right. Okay, so I'm assuming. So what I'm thinking, what I'm trying to figure out is, oh yeah, I have seen this before. In AR VR headsets, they track your eyes and they can see where your eyes are focused on. So this is so cool. So what's happening here is this person's wearing a headset. So this isn't like a, like, I'm assuming this is like, you know, whatever Facebook's latest headset is, which, like, who knows. I forget. But so the headset has cameras. There's also some sort of sensors, like some sort of camera sensors that look at your eyes. And then based on where your eye is looking in the camera's video, the SAM will run and then segment that image. And then, you know, I'm not the graphics expert, but then it'll do the, you know, the segmentation and then project it onto, like, you know, yeah. And look, yeah. So that's super cool. So I guess also, oh, okay. So the red dot is the gaze position. Wonder what the other things are. Maybe the blue dot is, I don't know. We'll find out. Just looking at, like, just peeping. So this is, I think I need to remind myself that this is image segmentation. This is not classification. It's not, I don't know, nothing to do with AR, VR, like this in particular. This is purely the segmentation task. This song is such a jam. Alright, so let me read through this again. Not again, let me read again, next part. Previously, to solve any kind of segmentation problem, there were two classes of approaches. The first, interactive segmentation, allowed for segmenting of any class of object but required a person to guide the method by iteratively... Wait, actually I don't know for sure that this doesn't do classification. It probably just helps it, but I don't know, we'll find out. Sorry. So previously, to solve any kind of segmentation problem, there are two classes of approaches. The first, interactive segmentation, allowed for segmenting any class of object but required a person to guide the method by iteratively refining a mask. The second, automatic segmentation, allowed for segmentation of specific object categories defined ahead of time. but required substantial amounts of manually annotated objects to train, thousands or even tens of thousands of examples of segmented cats, along with the compute resources and technical expertise to train the segmentation model. Neither approach provided a general, fully automatic approach to segmentation. SAM is a generalization of these two classes of approaches. It is a single model that can easily perform both interactive segmentation and automatic segmentation. The model's promptable interface, described shortly, allows it to be used in flexible ways that make a wide range of segmentation tasks possible simply by engineering the right prompt for the model. Wait, sorry, one more time. I'm a little slow. The model's promptable interface, which is described shortly, allows it to be used in flexible ways that make a wide range of segmentation tasks possible simply by engineering the right prompt for the model. Clicks, boxes, text, and so on. Okay. Moreover, SAM is trained on a diverse, high-quality dataset of over 1 billion masks collected as a part of this project, which enables it to generalize. Sorry, my mind, I went on a tangent thinking about the idea of prompt engineering, which I might have underlooked. It might make a little more sense to me, the idea of prompt engineering. Because when I've heard prompt engineering before, I sort of think of, it sounds like a buzzword to, like, I don't know. I'll refocus on reading this. So, how are we doing on time? Maybe 30 minutes. Moreover, SAM is trained on a diverse, high-quality dataset of over 1 billion masks, which enables generalized new type. Okay, let's. Oh, these are the things we were just watching. SAM allows users to segment objects with just a click. Or by interactively clicking points to include and exclude from the object. The model can also be prompted with a bounding box. SAM can output multiple valid masks when faced with ambiguity without the object being segmented. Okay, this is what we should have been doing instead of listening to me. So, can I restart it? So 1. SAM allows users to segment objects with just a click or by interactively clicking points to include and exclude from the object. The model can also be prompted with a bounding box. Like, yeah, so now this is giving me more weight to, like, the idea of, like, prompt engineering. So I get it. All right. So multiple valid masks when faced with ambiguity about the object being segmented, an important and necessary capability for solving segmentation in the real world. I like it. SAM can automatically find and mask all objects in an image, and then SAM can generate a segmentation mask for any prompt in real time after so SAM can generate a segmentation mask for any prompt in real time after pre-computing the image embedding, allowing for real-time interaction with the model. Excellent. And real-time is often defined as, I guess nowadays, I don't know, 20, maybe 24, I don't know. It's like, 30 FPS maybe. I don't know, but that's what we think real time. I guess real time is whatever's acceptable for your application. The latency being low enough, so maybe like 30 frames per second is what? How many milliseconds? Whatever. Okay, how it works. Let's do it. Oh wait, I think now it's time for the demo. Now that we're warmed up. Okay. All right, cool. This is about to be really cool. Let me recenter this, making these smaller. Okay. And I doubt you can read that, so I'll read it. So how to use the selection tool, let's find out. Add and subtract areas, mask areas by adding points, select add area, then select the object, refine the mask by selecting remove area, and then select the area. My brain is so not working. Mask areas by adding points. Select add area and select the object. Refine the mask. Alright, I guess we'll learn by doing. Okay. Oh. This is gonna be so fun. Wow. Cover and click. Oh, add mask or remove area. Let's see if we can move the snail. Multi-mask. Alright. Oh, this is a great demo. Okay. Oh. Move your cursor on or off the image to expand or collapse the layers. Okay. Box. Nice. Everything. Cut out all objects. Whoa. Okay. What's going on over here? Yeah, a little, nonsensical segment. Oh, I didn't see that. That makes sense. Alright. So, now let's do something cool, something fun. Let's, we are gonna segment a wedding photo. Alright, what should we do? What's a nice photo? Let's do me and the men. Men. Clearly, I'm obsessed with the fact that I'm married. Alright. Enjoy my photo, Facebook. Alright. Let's do it. Let's start off. Everything. Okay, it prompts him with a point grid. Okay. I am interested. We will check that out. So let's see how this does. It's getting all of our hair, which is looking nice. The tuxes. Okay. Oh, it's got the shoe. Nice, not bad. Like, it's like, here's this tree, here's this tree. Window, yeah, okay. This really is a masterclass in how to make a demo. Hover and click. Let's try the multi-mask. And let's see. Difficult. Let's give it a difficult challenge. Let's see how well it can segment our man Joey here. Oh, okay. So here, we move it off to. Sorry. So the overall one looks pretty good, but did I want to segment Joey, or did I want to segment his whole upper suit, or did I want just his vest? Okay. Okay. How do I? Okay. Oh, and then I could remove. What happens if I remove? Yes. Okay, yeah, you're like choosing things to remove. Okay. Look at how vain I am that I pulled up this image of me in the middle. Makes it interesting though, you know? Should we try a new photo? Maybe we could look at the gallery. They probably have some good examples. Ooh, that looks healthy. Extracting and embedding for the image. Okay. We got the top tier nut here. The best kind is roasted no salt cashews. Wait. Ah, Facebook, I spotted a bug. This is from the other image. So maybe we need to do the cut everything. So you should maybe gray that out. Anyways. That was weird. That's a little weird. Can I, yeah, let's, oh, there's an undo button, great. Look at this, so. Wait, what is happening? Oh, I clicked up, okay, that makes more sense. Alright, so, let's get some of these beats. Oh, this is the box. Alright, so. Okay. Let's try box. Let's see how many chickpeas we can get. Wait. That's fair. Maybe a little buggy. Let's try that again. So what I'm noticing is removing areas is like hurting it, I think. Alright, so here's how it is now. Let's take this out. Yeah. Let's take this out. Yeah, what? Did you see that? So I had remove area selected. And then, like, run that back. And then I tried to remove this, and then it added more. Excuse me. So this isn't, like, I don't know. That helped. We'll have to investigate, removing the area. Let's try again with this. So this is picking up particular chickpeas. I guess the idea is that... Okay. Okay. Yeah. Alright, so that was a pretty good example of this. So, with just a couple clicks, I guess we could say in a few shot setting, we got the chickpeas. Oh, I see. It saves your cutouts. Okay, so the multi-mask works. It's like a single click thing. What a bop. Okay. Do you have any other cool images I could upload? I'll use the one... Let's go on computer pics. Okay, I think we've done enough demoing, and... Are we still live? Yes. Okay, we're coming up in an hour, so I guess this will have been episode 1. So let's do this. This was episode 1, where we just explored it and talked about space a little bit. Honestly, I'm probably going to continue. Yeah, no, we have so much more of this blog to read. Okay. Maybe 15 more minutes. Okay, so here's the skim. How SEM works, universal segmentation model, segmenting 1 billion masks, how we built it, about the data set, what lies ahead, how SEM works, promptable segmentation, so it's probably about how you input it, universal segmentation model, so here's the model architecture. Yes, I'm segmenting 1 billion masks, how we built it. So we talk about how they built the data set and what lies ahead. This is like, imagine what we could do. Try the demo, learn more. Okay, so now I'll read more closely. We left off here. How SEM works, promptable segmentation. In NLP, and more recently, computer vision, one of the most exciting developments is that of foundation models that can perform zero-shot and few-shot learning for new data sets and tasks using prompting techniques. We took inspiration from this line of work. We trained SAM to return a valid segmentation mask for any prompt, where a prompt can be foreground or background points, a rough box or mask, freeform text, so, or in general, any information indicating what to segment in an image. The requirement of a valid mask simply means that even when a prompt is ambiguous and could refer to multiple objects, here, maybe I'll get that image in there while I talk. A valid segmentation mask for any prompt, where a prompt can be foreground or background points, a rough box or mask, freeform text, that's what I want to try, or in general, any information indicating what to segment in an image. The requirement of a valid mask simply means that even when a prompt is ambiguous and could refer to multiple objects, for example, a point on a shirt may indicate either the shirt or the person wearing it. We saw that in the demo. The output should be a reasonable mask for one of those objects. This task is used to pre-train the model and solve general downstream segmentation tasks via prompting. Okay. This task. Okay. We observed that the pre-train task, an interactive data collection, imposed specific constraints on the model design. In particular, the model needs to run in real time on a CPU in a web browser to allow our annotators to use SAM interactively in real time to annotate efficiently. While the runtime constraint implies a trade-off between quality and runtime, we find that a simple design yields good results in practice. Alright. So the model needs to run in real time on a CPU in a web browser. So I guess what it's saying is that's where the bottleneck is. It's like the bottleneck is that the CPU is running the web browser. So, you know, here's like the pipeline is that I'm on my computer through the browser. My computer's like, they're assuming the browser runs on the CPU. And then when I click my click gets sent over the network and then runs on their model and then is sent back to me. So it's not about it's not real time. It's not about getting the latency down to run on big infrastructure. It's about getting it down so that I can work in a web browser. So makes sense. Under the hood, an image encoder produces a one-time embedding for the image, while a lightweight encoder converts... Okay, so here's where things get interesting. Under the hood, an image encoder produces a one-time embedding for the image, while a lightweight encoder converts any prompt into an embedding vector in real time. Image goes into an image encoder, then we have image embeddings. The prompt encoder a lightweight encoder converts any prompt into an embedding vector in real time. Okay. These two information sources are then combined in a lightweight decoder that predicts segmentation masks. After the image embedding is computed, SAM can produce a segment in just 50 milliseconds given any prompt in a web browser. So it gives you the masks and their confidence scores. Okay. So, sorry, what is this? So, I guess we'll find out. I'm not sure. So, this all, at a high level, everything makes sense except what's this component? Like the mask getting added, but the user isn't inputting a mask. The user's inputting either, points or the box or the text. Let's find out. Okay. To train our model, we need a massive and diverse source of data which did not exist at the start of our work. The segmentation dataset we're releasing today is the largest to date by far. The data was collected using SAM. In particular, annotators used SAM to interactively annotate images. Okay, I see. And then the newly annotated data was used to update SAM in turn. We repeated this cycle many times to iteratively improve both the model and the dataset. With SAM, collecting new segmentation masks is faster than ever before. With our tool, it only takes about 14 seconds to interactively annotate a mask. Our per mask annotation process is only 2 times slower than... Okay, so this is for... I'm not sure. I think this is for, so we think about training time, we think about inference time, but I guess we now need to think about fine-tuning time, which I guess is part of training time, but, or rather, what I was going to say, we need to think about data set creation time. I don't know. In context of the architecture, I think this is not really training time, not really inference time, but this is the architecture for dataset creation time, I think. Let's find out. Okay. So yeah, so they use SAM to make this data set. With SAM collecting new segmentation masks is faster than ever before. With our tool, it only takes about 14 seconds to interactively annotate a mask. Our per mask annotation process is only 2 times slower than annotating bounding boxes, which takes about 7 seconds using the fastest annotation interfaces. In comparison with previous large-scale segmentation data collection efforts, our model is 6.5 times faster than the COCO fully manual polygon-based mask annotation, and it's so interesting. Like, so this is now, we're now benchmarking this against other annotation tools. This is what the lab I'm part of works a lot in, is the crowdsourcing space, and also in like the human focused elements, because there's, you know, HCI in a lot of dimensions. Okay. However, relying on interactively annotating masks does not scale sufficiently to create our billion mask dataset. Therefore, we built a data engine for creating our dataset. This dataset has 3 gears. In the first gear, the model assists annotators. The second gear, is a mix of fully automatic annotation combined with assisted annotation, helping increase the diversity of collected masks. The last gear of the data engine is fully automatic mask creation, allowing our dataset to scale. Our final dataset includes more than... Sorry, I read that, but I didn't... Oh, my brain wasn't on for it. The last gear of the data engine is fully automatic mask creation. Okay. So I'd like to see, do they have... They don't say the proportion of... Or, not here at least. I'm wondering... Oh, we have a better architecture here. Do they say the proportion of what's human, partial or fully? What's the proportion of the gears? Yeah, maybe. What's it say? Stages: manual, semi-automatic, automatic only. This is gonna be good. This whole you know, hour we spent will be a good primer for going into this. Okay. Our final dataset includes more than 1.1 billion segmentation masks collected on about 11 million licensed and privacy-preserving images. Good call. SA1B has 400 times more masks than any existing segmentation dataset, and is verified by human evaluation studies. The masks are of high quality and diversity, and in some cases even comparable in quality to masks from the previous, much smaller, fully manually annotated datasets. Images and data set. Wait. Oh, there's a... Okay, alright. So, a distinction here is that there's a billion segmentation masks. There's 10 million images. Yeah, just a little distinction. And it is by far a lot larger than the previous. I don't know if these are. Oh, so I guess what they said is that previous large ones are annotated, also using tools like this. Okay, and then here we go, the masks. Yeah. So. Yeah, billion masks. It sounds sexy. I don't mean the song, but a billion masks sounds sexy. It shows the power of like the AI, that you can like get this many things. I guess if you, I'm just thinking about like quality control, but I'm sure they have good methods for that. Images were sourced via a photo provider from multiple countries that span a diverse set of geographic regions and income levels. Wow. While we recognize that certain geographic regions are still underrepresented, thank you for the transparency. These guys are really like nailing it in the like how to do AI research in 2023. Because these are like very real and valid concerns, and they're like hitting them all. So good work. SA1B has a larger number of images and overall better representation across all regions than previous segmentation datasets. Moreover, we analyzed the potential biases of our model across the perceived gender presentation. Someone give a presentation about benchmarks and datasets being a source of bias and stuff, and I want to find that person so I could send them this and point it out. I think they'll be happy about this tidbit. Moreover, we analyzed potential biases of a model across perceived gender presentation. There's like multiple studies going on in this study, multiple projects. So we analyzed the potential biases of our model across the perceived gender presentation, perceived skin tone, and perceived age range of people, and we found that SAM performs similarly across different groups. Together, we hope this will make our work more equitable for use in real-world use cases. While SA1B made our research possible, it can also enable other researchers to train foundation models for image segmentation. We further hope that this data can become a basis for new datasets with additional annotations, such as a text description associated with each mask. So, yeah, a basis for new datasets with additional annotations, just text description. So yeah, this puts the nail in the coffin to my question I had earlier. Like, this is just segmentation, right? It's not classification. But now that we have this giant segmentation data set, we can now have it can hopefully turn into a giant classification data set. Like, it seems super possible to me. They're like basically giving you the layup. Okay, so what lies ahead? Let's look at these. In the future, SAM could be used to identify everyday items via AR glasses that could prompt users with reminders and instructions. So not actual product footage, this footage is strictly for illustrative purposes only. So the idea is like, Here's a cooking bowl. Would you like to pull up a video of Carla's icing tips? Rex was last fed 20 minutes ago. Wow. Now think about this in the interior design space. Like, for the minimalists out there, you can choose options, like, instead of like a gross whiteboard I have here. I don't know. You could, yeah, I don't know. It's just, let your imagination run wild. Sam has the potential to impact a wide range of domains, perhaps one day helping farmers in the agricultural sector or assisting biologists in their research. Yeah. By sharing our research and data set. So I guess what they're sort of doing here too, which I think is effective and is they're sort of like they're really being like, think of all the ways, like all the negative stories are what make the headlines and get views and everything, but they're like, think of the possibilities of all of like the helpful, productive things we can build, and it's really awesome. Like, think about all of the like people hard of eyesight that could use this. Blind or semi-blind. Like better future workers. So by sharing our research and data set, we hope to further accelerate research into segmentation and more general image and view understanding. Our promptable segmentation model can perform a segmentation task by acting as a component in a larger system. Composition is a powerful tool that allows a single model to be used in extensible ways, potentially to accomplish tasks unknown at the time of model design. We anticipate that composable system design, enabled by techniques such as prompt engineering, will enable a wider variety of applications than systems trained specifically for a fixed set of tasks, and that SAM can become a powerful component in domains such as AR/VR, content creation, scientific domains, and more general AI systems. As we look ahead, we see tighter coupling between understanding images at the pixel level and higher level semantic understanding of visual content, unlocking even more powerful AI systems. This is my jam right here. Okay. In the nighttime. Speaking of nighttime, why aren't I doing this? Okay. Yep, coming up on 2 a.m. So we demoed it, we read the blog, we had the download paper. I now have software to mirror my iPad. Here's the data set. How big this is? Probably huge, right? I don't want to like hit download. Is it in here? Does it tell us? Assets. I mean, like, disk space. I guess we can do some quick math. Excuse me. A high quality JPEG might be a megabyte. So, wait, 11 million or 1.1? Oh, 11 million. Oh yeah, just above 10 million. And sold ourselves a little bit short. I think I could have gone up to here. But so 11 million unique, diverse, high quality images. Does it say here? Oh, okay. Average image resolution, average mask image. Nice. So here we can do the quick math. That. Okay, still, I guess we'll. Alright. I don't know about dealing with compression, and then also what's the, like, number of bytes per pixel value. But, alright, so say there's 1 megabyte an image. Then 11 million images is, it's gonna be, alright, so 10 to the, just doing an exercise here, guys. Let me do my little math exercise. So a megabyte is 1,000,000 bytes. That's 10 to the 6. And then, so it's 10 to the 12. So wait, so 6 is million, 9 is giga, and then 12 is tera. So it's probably not that much, but if every image was a megabyte, then I guess this data set would be a terabyte. Alright. Oh, but it's a text file. Oh, a text file with all the links that can be downloaded. Oh, okay. Alright. Oh, interesting. Okay, I'm still confused about how big this is. Okay, but so this is how you would go about getting the data. You download this, and then you use like a command line tool like wget to download these compressed. Are these? I guess these are folders, compressed folders with all the data. Okay. Oh yeah, and then this is my template I put in the description if you want to use it for reading this paper too. So next time we will read this paper, or we'll at least make our first pass through the paper. Oh, this is interesting. I guess we can make our first pass right now. They show they show a lot more about like, you know, the contribution. So Alexander Carroll and Nakila Ravi are the project leads. We have 4 joint first authors. Contribution, director lead, and then it's interesting. Okay, and then maybe like a quick look at this architecture. How about that? So the task is promptable segmentation. The model is the segment anything model, SAM. Then the data is in its data engine, and that makes the data set. So this is the figure that tells it all. So we aim to build a foundation model for segmentation. Said this a million times. Yeah, so we've been over this. I feel like we've already read this paper. This will just talk about. So let's look at the heading. So the intro. Which seems to include some related works type things. Release examples of overlay tasks. Segment anything task. Okay, so here's the model architecture. Oh, we already looked at this, I think, actually, but this is what I was curious about. A heavyweight image encoder outputs an image embedding that can be efficiently queried by a variety of input prompts to produce object masks at amortized real-time speed. For ambiguous prompts corresponding to more than one object, SAM can output multiple valid masks and associated confidence scores. So it's cool. It's like, yeah, you could say like, I want to see that in action. Oh, do we have results of that in this paper? I'd like to think we must. Well, while we're scrolling down, let's see, what are these? Oh yes, they really are showing what they it wasn't just fluff, or they at least have numbers to back it up. I mean, we do see there's a lot more from Russia. Sorry, what is THA? Thailand? Excuse me, being geographically challenged. Per country image count. Okay. Yeah, a big part of this really is the data set. From my perspective, it's kind of like Whisper, where it seemed to me that a big part of Whisper was just the aggregation of the data. Hopefully I'm not, I didn't just say something that's not true. So, okay, zero-shot transfer experiments. SAM uses an MAE pre-trained VITH image encoder. The only thing, I'm going to be honest, the only thing I recognize is VIT, Vision Transformer. And even then, I don't have it really marinated yet. But I'm on my way. And here's some more motivation to get there. Samples from the 23 diverse segmentation datasets used to evaluate its zero-shot transfer capabilities. Yeah, I like having some trouble looking at, thinking about what I'm looking at. Alright, so... Okay, so, alright, so first of all, Okay, samples from the 23 diverse segmentation. Oh, okay. So here we have distinct image data sets. I mean, by distinct, I mean diverse, like from different domains. Like they said, underwater, hyper, I don't know what that is. Cityscapes. All right, here we go. The cell biology one. So it's like tying it to the beginning. It's a foundation model that wasn't trained on like these domains, these like distributions of photos. But now given like it wasn't trained on underwater images, but this is how it does on some underwater images. Like, so nice. So that's what this is illustrating. I get it now. Brain turned off for a second. And then here we have ZAM versus RITM. RITM must be the other latest one. I guess it's the other interactive segmentation. I'm not sure. Okay. But anyways, point to mask evaluation on 23 data sets. So so here's the data sets on the y-axis. The mean IOU of SAM and the strongest single point segmenter. Oh, so okay, yeah. So the strongest single point segmenter. So this is the other interactive like segmenter. And IOU is intersection over union. I'll pull up a picture so that just marinates. So yes, the IOU is the like overlap of so the overlap of like, so say this is the mask and this is the ground truth. It's the intersection over the whole thing, and that's the measurement used in segmentation. Okay, and then let's take a look at these two, I guess. Mask quality ratings by human annotators. Oh, okay. Out of 10? Yes. Oh, let's read this. Due to ambiguity, a single mask may not match ground truth. Circles show oracle results of the most relevant of Sam's 3 predictions. Oracle results? Moving on. Per dataset comparison of math. So I'm looking at B now and reading down here. Per dataset comparison of mask quality ratings by annotators from 1 to 10. All methods use the ground truth mask center as the prompt. That's just I got so confused. I thought the census was continuing. CD is talking about C and D. Okay, so yeah, so this is the mask rating. yeah, so here's the data sets. They sort of normalize this graph on eye shape. So I would have liked you to show 10 though. But I guess, you know, it's all sort of relative to, but they're showing, okay, wait. Oh, okay, so the ground truth, so the ground truth, there's two things to mention about it. One is that this is what the humans rated the ground. Oh, okay. So yeah, because the ground truth, some of them are like AI generated too. So, so the humans ranked the ground truth's segmentation. Wait. Oh no, these are other data sets. Okay. That were probably manually labeled. So anyways, this humans rank the ground truth and they rank the other models. So so when they rank them, are they shown, I guess they're shown multiple outputs that they rank. They tend to rank that higher. And they rank single output, and they are showing that, you know, we get a couple points over the last best one. Rhythm. I forget what it stands for. Something interactive. Alright, I probably need to go to bed. A bit disgusting. Yeah. We're gonna look way deeper at this another time. But thanks so much for tuning in. Like, comment, subscribe. Don't forget to nourish your relationships. All right.